Hello and welcome to our YouTube tutorial on anomaly detection in retail sales transaction using AI in data engineering. Today we are going to explore an exciting use case that demonstrates how to identify unusual and potentially fraudulent activities in a retail company's sell data by leveraging artificial intelligence techniques within the data engineering domain. Our goal is to provide with you hands-on experience and insights to help understand the process of the detecting and handling anomalies in large dataset. To begin, let me present a scenario that we will be working with. A retail company has a large volume of sale transaction and is inserted in detecting anomalous transactions such as an unusually large purchase or transaction involving a high number of the different products. By identifying these anomalies, the company can take appropriate action, like alerting fraud detection teams, reviewing business process, or improving their quality. Why use AI in data engineering? AI and machine learning can help data engineers by automating repetitive tasks, improving accuracy, and making more informed decisions based on the data. This example using an isolation forest model to detect anomalies in retail sales transaction can help the company identify unusual behavior and act accordingly. In today's tutorial, we will delve into the fascinating world of the anomaly detection using the isolation forest algorithm with the PySpark. But first, let's address a crucial question. Why isolation first? Isolation first is a powerful algorithm designed for efficient and effective anomaly detection. Traditional often struggle with the high-dimensional data and complex relational between features. Isolation first, on the other hand, excel in isolating anomalies by focusing on the inherent characteristics that make them stand out. Okay, what is the isolation first algorithm? The isolation first algorithm is a tree-based model that operates on the principle of the isolation anomalies rather than profiling normal instances. Okay, and isolation first algorithm has some features like randomized partitioning, anomaly scoring, and ensemble of trees. Okay, and why isolation first stand out? Efficiency, scalability, and versatility. In our tutorial, we will talk through the practical implementation of the isolation first using PySpark, demonstrating how it can be a game changer for identifying outliers and anomalies in your data. You can observe a data flow diagram that retrieves data from a streaming source such as Kafka and so on. The data is then stored in a data frame, and anomaly records are detected using isolation first for each customer ID. This detection is based on the comparison of the product list within each customer's set, which stores all the records containing. The result are stored into two tables. First being the retail sales transaction table, which stores all records containing both non-anomalous and anomalous transaction, and the second being the anomalous transaction table, which exclusively holds the detected anomalies records. Okay, now let's dive into the code and see how we can address these real-world scenarios using advanced data analysis techniques. We will be working with this data set containing customer ID, transaction, and list of the product ID. And our task is to find anomalous transaction using the isolation fallacy algorithm from scikit-learn. Here we go. First of all, import necessary libraries. Okay, next step is create a Spark session. Okay, and define the data for a sales transaction. Okay, and define the schema for data frame. We have 3 columns in data frame. First, customer ID, you can see here, and next, transaction ID, and finally, product ID list. Okay, it's array. It's array contain forecast list for each customer. Okay, and create a data frame. Okay, and next, handling missing value in product list. Okay, and partition the data before training, optional for large datasets, and adjust partition count as you need it. Okay, and create delta table for create data table for retail sales trends. Okay, you can see here this script. I use a SQL Server script, and I use a SQL Server script, and I create a table, delta table, same as columns in data frame that I defined it already, but I add anomaly key and create datetime and ID to this table. Okay. Okay, And next table is create the second table is anomalous transaction. Okay, we created the anomalous transaction delta table. Okay, and I add ID and anomaly and anomaly key and create date time to data frame and create this table based on these columns. Okay, and this table keep records that detected as anomalous records. Okay, and here next step is identify unique customers. Okay, and here I want initialize isolation forest model. These parameters are essential for configuring the behavior of the isolation forest model. The continuation helps in setting in the threshold for what is considered an anomaly, and random states ensure that our random process are reproducible, providing a consistent result across a different run of the algorithm. Adjust these parameters should be done based on the characteristic of your data and specific requirements of your anomaly detection task. Okay, and next step is initialize a new data frame for anomaly prediction. Okay, next step is create a loop. Iterate through each customer, and anomaly prediction loop iterate through each unique customer. Filter their transaction and train the isolation first model and predict anomalies. Okay, I want filter transactions for the current customer. Okay, and next step is a check for empty data frame. And here I want extract product list as a list of numpy array. And I want to convert the list of numpy arrays to the array two-dimensional array with the padding. Okay, and I implement try and catch for razor handling. In the model and customers transaction. And I add the anomaly prediction to the original data frame. And create a prediction data frame handling potential empty transaction ID list. And else handle the case where there are no transactions for the customer. Okay, and execute. Okay, and next step is merge the anomaly anomaly prediction data frame with the original data frame. Okay, and add anomaly key and create the time to the data frame. Okay, here filter just records with -1. -1 is symbol of anomalous records. Okay, I want this expression. I want just records have anomaly key. That anomaly column value equal -1. Okay, and next step is drop the anomaly column, because we don't need anomaly column in retail sales delta table. Okay, and finally, we want to write our records, anomalous and non-anomalous, to retail sales transaction table with the schema merging. Okay, and display the contents of the retail sales trends. Okay, you can see right all of the code. Okay, and here the anomaly key shows just two key are just two records are detected as an anomaly. Okay, and next step, filter anomalous records and create a unique anomaly key and create date. Okay, I create a data frame and filter just anomalous transaction. Okay, here you can see here, and add two column anomalous key and create date time. Okay, and finally insert data in anomalous transaction table and display it. Okay, I back here and copy and paste it because I want compare two tables. Okay, print. And here. Okay, you can see final result. We have the two tables. The first table, retail sales transaction, keep all data, anomalous and non-anomalous data. And here, and in second table, anomalous transaction, just keep anomalous transaction. You can see here, and based on this column, you can perform join between two tables. Okay, thank you very much for watching. Have a good day.